look at our robot. What mechanical tools do we have to accomplish this? It's a two-wheel drive basic bot. It has DC motors with encoders.
We need to take a deeper dive into how the encoder will work to solve this problem.
This Tornado DC motor has a built-in encoder and a 60-to-1 gearbox. We know the encoder outputs 1,440 ticks per revolution of the motor shaft.
We know that the wheel has a 4-inch diameter, and when we multiply that by pi, we'll get the circumference of the wheel.
If the circumference of the wheel is 12.6 inches, then the encoder output equals 1,440 ticks or pulses for every 12.6-inch revolution of the wheel. Let's look at the math. We need to determine the distance traveled divided by the circumference to get the number of revolutions. Then, we need to multiply the number of revolutions by the pulses per revolution, which we know is 1,440.
So n equals distance traveled divided by circumference.
D equals the length of our segments divided by 12.6, the circumference of the wheel.
Here's the calculations for all three segments.
We have what we need to solve problem number 1. So let's map out what we need to know about the motors to drive straight for a certain distance.
We need to know how the motors are set up.
You can see that the motors are positioned opposite one another, so one motor has to go in reverse, so they are both spinning clockwise or counterclockwise at the same time to move. Let's write the move to position function. We can use this for all three segments by changing the distance traveled.
Here's the completed function. You can see where the sequence of steps is to turn the motors on to a certain power level, drive the required distance, and turn the motors off.
Before we get started, make sure you have the correct robot configuration file. Then, in Robot Controller Console, select blocks in the upper left corner and choose the op mode we created in the previous video.
First, we want to delete the if-do logic block and the run up mode function. Let's make a function that can be used again. For this function, we're going to name the input. Go to Functions, select the first option, and place the block in the work area. Then, replace do something with move to position to give the function a name. Then, select the gear icon, input name, and in the input box, replace the X by typing target position. This will create a parameter variable that we can use later.
We get a comment block from the miscellaneous tray and place it in the function and type reset the encoders. Now we need to reset the encoder so it will start at 0. Go to Actuators, DC Motor, Dual, and select the Set Mode block, and change both modes to Stop and Reset Encoder.
Let's add a comment to put the motors in encoder mode. Then we go to Actuators, DC Motor, Dual, and select the Set Mode block, and change both modes to run using encoder.
Next, we're going to set the power. Let's add a comment. Go to Miscellaneous, select the comment block, and place it below the Run Using Encoder blocks. Change it to Turn on Motors. Now, go to Actuators, DC Motor, Dual, and select the Set Power block. Change both power levels to 0.3.
Now we'll add a comment for a loop that we're about to create. Go to Miscellaneous, select the comment block, and change it to loop until the motor reaches its target position. Place it under the power block.
Let's create a while loop that will determine the distance traveled. Go to the loop tray, select the repeat while block, and place it under the loop until comment.
Now let's create some logic to get to our measured distance, which we will call the target position. Go to the logic category, select the equal sign block, and place it in the repeat while. Change the equal sign to a less than sign. We want the motors to stay on while the left motor's current position is less than the total distance we want to travel.
To do this, go to Actuators, DC Motor, then select the left motor current position block, then place it in the left side of the less than 2 block.
Now go to Variables to get a copy of the variable called target position. This variable was created for us when we filled in the function block earlier. Place it to the right of the less than. Now let's put a comment in the do part of the repeat, indicating that we don't need the function to do anything while it's waiting for the robot to reach the target position.
After the robot has traveled the distance of the first segment, we need to turn the motor off. Go to Actuators, DC Motor, Dual, and choose the Set Power block that has 2 zeros, and place it in the function. Finally, we need to put the function to sleep for 1/4 of a second to give the robot time to stop. We need to add a comment saying that is what we're going to do, and then select a sleep block from the first tread. Place in the function and set the sleep time to 250 milliseconds.
Now we have what we need to move forward various distances.
We'll use this function later each time we need to move the robot forward a certain distance.
Join us next time where we'll solve problem 2, rotating the robot.
Goodbye, everyone!